Hello students, I hope you're all doing well and enjoying your vacation. I am Dr. Mohamed Ashour, and in this video I'm going to talk about bachelor projects that are related to smart sports system. There are three projects that I'm offering this semester, which is machine learning based athletic video performance analysis, machine learning based athletic sensor performance analysis, machine learning based localization. What are the problem we are trying to solve? The problem is that competitive sports requires very accurate movements to achieve the highest level of performance. This is very important in sports like running, swimming, and so on, where each small move could make a difference in the final timing of the race. The problem is that using normal coach eyes cannot identify defects or advantages in the athlete movement. And it is required to use videos or sensors or recording of different athletes to identify the way they move and to identify the advantages and disadvantages of each athlete. The first project that we talk about is machine learning based athletic video performance analysis. And in this project, the objective is to use ESP cameras to take pictures of an athlete, in this case here a swimmer, from different sides. So in this example, we're taking a picture from the side and from the front. These pictures would be sent to a local server using Wi-Fi. And in this case, you would do something similar to what you did in the internet, where you build a server, a connection, and you regularly send the pictures to that server. On that server, we will need to run Python machine learning code that actually detects these images or these points that you see in this video. These points are the points that represent the joints of this athlete. By connecting these points, we can know an approximate idea about the orientation and of each body part. That has to be done over different pictures, and it has to be done from different aspects. So it can be done from the front and from the front here and from the side. And then we would need to tune the model so that we can have a better estimation of that athlete. For example, we have to train the model to know that this point is the same as this point. This point is the same as this point, and so on. And that could also be used to correct a lot of the problems in the model, because we can see here that the model, for example, in this part did not correctly detect the part of the joint. It detected it a little bit higher. Then what we get from this model, we will have to build our own machine learning approach to transfer this 2D model into a 3D model of the athlete. That 3D model is then used to measure the speed of different parts of the athlete, like you see on this image, where we're measuring only the movement of one leg. So we can measure the angle of this upper leg and lower leg, and how this angle changes as this person moves forward and to doing one complete step. The progression here over time gives us the speed that this angle changes with, and would also gives us a measure of that angle. That could be used later to say whether this, for example, in this case, if this person is only moving, if he is moving correctly, that he's taking the right steps, that he's moving his legs in the most efficient way. So we will need to build a code to measure the speed and the angle of movement of different body parts that are detected using this human posture detection. And then we would build a dashboard to display these results, for example, like this one. And we build a simple user interface for this application. This is a very nice project, a very simple project. a project that is fun to work with. It is also a project that has applicable outcome or practical outcome, and it also has a research outcome and could be used to produce either a real application to assess the performance of athletes, or the results could be used to publish papers in international conferences. Another important project is doing the same thing but with sensors. The problems or the challenges here is that using sensors, the readings are noisy. It's not as clear as it is with the camera. It is difficult to transform the readings to measurements. If we're using an electronic device to record the movement, then this device has to be very efficient in terms of energy because it will run on battery. It also needs to collect as much data as possible, but in the same time it has to have a very small processor. So this is a challenge. It also has to be able to connect to the server and to keep recording the data when the connection is lost and then reported later. So basically this project would, what it will do is that it will use a design of an electronic measurement device that we have already built in previous projects. This project, we will start using this instead of designing. So we will have to build a printed circuit board and manufacture it, and manufacture different versions of this device. We also have to build a 3D printed waterproof casing so that we can mount this device, for example, in this small pocket on the back of the athlete. And you might notice that this is very similar to the device that you see a lot of football players wearing, but football players use a small black vest in order to wear this device. And then we need to tune the software of this device so that it is very power efficient and enable it to collect as many data as possible. This data is reported regularly to a server, and the device software needs to be modified to store the data on the device when the connection with the server is lost, and then stream it to the server when the connection is restored. Once all that is done, then we will take this device and actually mount it on an athlete, and we will ask this athlete to do a movement that we know about. For example, we will ask him to run or to walk or to do an activity that we know. We will also try mounting this device on different locations, so it can be mounted on the back, on the hand, actually on the leg, and we can use multiple devices if needed. The data that results from this device would be a measurement of the angle changes on different dimensions, so in the Y, X, and Z. It could also report the acceleration on the 3 dimensions. So using these data, which is like the one that you see here, we can start recording and say, for example, that every cycle of these cycles represents one step. We can see the force of these steps. We can see how these steps, for example, in this case, if this is the sensor mounted on the hand, how that is related to the sensor that is mounted on the foot, and maybe also to the sensor that is mounted on the back. And these results could be used to assess the performance of the athlete. This is again a very practical project. It includes learning a lot of skills like building 3D printed models, building circuit boards, writing softwares for IoT, data analysis, machine learning, user interface. These are all very important skills that you can learn in this project, and that could actually be important things in your CV. Another important aspect is that this project could be used to either generate a product actual software that could be tested or that could be used by GUC athletes and maybe later marketed. Or it could be used to generate scientific research about how to measure and so on. In both cases, students who are smart enough to be able to reach this level will have this as part of their CV, which is an item that can make them distinguished from the others. Coming to the last project in this set of projects, we are going to talk in this project about machine learning based Bluetooth localization. In this project, the objective is to be able to locate the player inside a playing field. Currently, this is done through GPS, and the problem with GPS is that it consumes a lot of battery and it might not provide the most accuracy within such a small area. The idea here in this project is to locate a number of Bluetooth receivers on the edge of the playing ground. In this case, we're assuming that we're using a football field, so we will locate a number of receivers on this football field. These receivers would be built using ESP32, and the ESP32 is the same as the one that you used in your internet project in the 5th semester. They will do a very simple task of only receiving Bluetooth beacons and sending it using Wi-Fi to a server. So how the project will work: each player will wear a device. This device will regularly transmit what is called a Bluetooth beacon. This beacon is a regular signal that contains the MAC address of the device of the player. This signal would be received by all these anchor points, and a technique would be used to find the location of the player in the field. The work in this project would contain first to use the athlete device to generate a beacon signal. This beacon signal, the amount, how many signals per minute or per second, has to depend on the rate of movement. So the device worn by the athlete would have a gyroscope that would and an accelerometer that would decide how much he moves. Using this information, we can either increase or decrease the amount of signal that is transmitted by this player. We have to find a way of including the angle and acceleration of each player inside the beacon, which is the signal that is transmitted regularly. Then these number of ESP32 anchor points would receive the signal and transmit it using Wi-Fi to a server. At the server, we would use a localization technique to determine the location of the athlete inside the field. We will mainly try two different approaches. We will try an approach that is very similar to tritylation. It's a little bit simpler. It's called bilateration, not trilateration. And we will also use fingerprinting that you guys have already tried in your wireless or mobile course. This technique would usually give not a very accurate location, and this is where machine learning comes in. We will use information such as the old location of the user, the angle and acceleration data, the location of other players, to enhance the location of the current user and to make it of the current player and to make it more accurate. The objective really is to produce something that looks like this, where it is a field and each point here represents the player location, and this arrow or line represents the direction, and the length of the line represents the speed of the player. So we can see on this on this map that how players are currently moving and the speed by which each player is moving. Uh, Again, machine learning can be used to provide an accurate description of this. And in this case, it is required to build a simple user interface that could be built using Python Qt to show something like this. Then the locations over time can be used to derive other measurements. Like for example, in this diagram, the measurements over time is used to provide what is called a heat map, and the heat map here displays the percentage of time the players were located at a certain location in the field. This diagram actually shows that this game was mostly played on this side, which means the green team was always on the defense, and the red team was always on the offense, and most of the game were played inside this part of the field. At the end of this project, we will have a small GPS transmitter added to this device on the back of the player, and we will try to compare the accuracy of our own techniques to the accuracy of GPS measurements. This is quite an interesting project. First, because it is a fun project. It includes a lot of work in the football field. It is also a project that can generate a very nice outcome. It's interesting. But also because although we're doing it for football, that same application could be used in so many other places. It could be used in malls, it could be used in museums, it could be used inside, for example, a place like the university, and so on. So it has so many other applications that could be useful in so many other ways. This comes to the end of the projects that are offered under the umbrella of Smart Sports. I hope that you like these projects and that you would join and choose these projects as the projects that you would be willing to do in your bachelor. Thank you and have a good holiday. Bye-bye.